let's just talk about, in maths, the terms reflections about the axes, okay? It's something that comes up time and time again, is when we reflect about an axis, okay? They're going to give you, for example, various graphs and ask you to reflect this about the x-axis, reflect it about the y-axis, and what happens to the graph, to the equation itself. So first of all, let's have a look at the word reflection. Okay, what is a reflection? Now, once again, just to get the concept, if you look at a mirror, stand at a mirror anywhere you like, please do it, because it clearly shows you what actually happens. If you stand at the mirror, okay, I'm pretending now that the camera is a mirror. Between myself and the camera, I can see everything in between, right? So in the mirror, what do I see? I see everything in front of me going from the mirror backwards, don't I? So if I have this, let's say I have me, maybe I have a box, and let us say we've got a pot plant over there like that. And we put a mirror over here, okay? I see these are the objects, right? This is an object, isn't it? Where do I see this? Well, where do I see the pot plant? Okay, I see the pot plant exactly the same distance behind the mirror as I do ahead. Where do I see the box? I see the box exactly the same distance behind the mirror. And lastly, where do I see me? I see myself exactly the same distance behind the mirror like that. Okay? So I see everything behind the mirror. So if we are reflecting about the y-axis, I see everything equally behind there. Okay? So we pretend that's the mirror. And if we are reflecting about the x-axis, right, reflecting about the x-axis, I see that as my object. This is the mirror. Therefore, where's my point behind? My point behind is exactly that far, and we call that the image. All right? Okay. For those of you who go on to do optics at physics at university, those of you going into optometry or whatever, that's the stuff you're going to be talking about, with lenses and images and virtual images and things like that. Now, so how do we reflect graphs then? Okay. Well, the best is to start with a simple graph. Let's try a very easy graph, shall we? Okay, what's the easiest graph we all know to try? Oh, hang on, y equals x. Okay, there we go. Sorry, that goes through the origin there, right? And we've got, let's just take point 2 and point 2. And over here, let's take point -3. And that's point -3, right? So that's the standard graph. So let's put down our coordinates 2 and 2, and -3 and -3. Those are our ordered pair, aren't they? Now, this is the graph, y equals x. Now they say to us, reflect that about the y-axis. All right, well, let's do it. What it means is it means that the y-axis becomes the mirror now, doesn't it? Therefore, any point that I've got, which is my real objects, these are my objects. The black ones are my objects. This is my object. Okay, those are the objects. They're the ones that I know. They're real. Now, where does the image go, right? We say if we've got a mirror there, the y-axis, it means the mirror image, this is the object, it means it's that far behind, which is at -2 and 2. Can you see that? So this then is my image. Is it -2 and 2? Well, let's have a look what happens to the -3 and 3. Remember, this is my object here. So where's my image? It's going to be, there's my mirror, right? There's our mirror. It's going to go to 3 behind it, isn't it? Okay. It's going to be at 3. minus 3, 3 and minus 3. Right? So what we've done now is we've done this, and essentially we've gone the line y equals minus x. Okay? So when we're reflecting about an axis, take whatever points you've got, or you can plot and reflect them about the axis. Okay? Let's look at this one. All right? Let us take a graph. I've just done one here. What about this graph? Right? Let us just see what happens now. Okay? All right? This is the graph of y equals half x minus 2. Well, first of all, we need to draw that graph. Okay? So we say, okay, we go through. If x equals 0, y is minus 2. We knew that because minus 2, 0, like that. And if we solve the other one, you put y equal to 0, and you get x equal to 4. So it's 4 and 0, and we can then draw the graph going up like that, and we label it y is equal to a half x minus 2. There we go. Now, let us reflect this about the x-axis first. Now we're changing it. Okay, so let's call the x-axis, I'm going to do it in red. Okay, this is our mirror. Okay, so any point that we've got, we're going to reflect about that line. So what do? I say, okay, here's a point. This is an object. Remember, this is the black. This is an object. Okay, so now where do I put it? I put it on the opposite side of the mirror, equally far away. My x is 0, my thing is plus 2. So my new graph is going to be there. This is the line y equals, hold on, we don't know. Okay, we're going to have to work it out. So as a revision, we're going to go and work out the equation of that graph. Okay, but hopefully you can see that. It's quite straightforward, huh? Okay, all I did is I found out where my mirror was, and I took any point. I could have taken any other point and reflected that as well. But surely you can see here that all of those, and this one was up there, and it's now gone down there. Okay? So we've reflected it, and it looks like that. All right? Let's look at what is the equation of this line. All right? What do we do first? First we say y is equal to mx plus c, and let's put in any points we know for the red line. Let's do it in red now, right? So, do I know? Hang on, I know c. c is plus 2. So, therefore, y is going to be mx plus 2. How do I find the rest? Do I know any other points? Yes, I do. I know that we've got x equals 4 and y is 0. M times 4 plus my 2. Right? So, therefore, m in this case is going to be equal to minus a half. So the graph of this guy is y is equal to minus a half x plus 2. Okay. Can you see? Okay. Now, it's easy to work it out, okay? Because you can actually put in the points and solve for it. I just did that over there now, minus a half. X plus 2, all right? And that gives us the reflection. So actually, we changed that, and the gradient went from a half to that. So essentially, I multiplied by minus 1, okay? Now, of course, you can remember that if you want to. If you're reflecting about the x-axis, you multiply by minus 1. Let's have a look if we're going to reflect now about the other axis, all right? Okay? Right, I'm now going to reflect about the y. So the y becomes my mirror. Okay, now I've got a point over here. Can you see it? There. So now that's got to go to, oh, hang on, minus 4 and 0. All right? Where does this point go? It doesn't. It stays in the mirror. So now I've got one doing this, haven't I? Got a graph doing that now. Okay? So we say, okay, what do we do with this then? Well, once again, we know it's a straight line. So let's do it in blue. Right? Y is equal to mx plus c. What do I know? C is minus 2, so put it in. Y equals m times x minus 2. There it is, right? Goes through there. And put in the other points that we know. 0 is equal to m times minus 4, minus 2. Okay? Therefore, we can solve, and we can say, okay, therefore, 2 equals minus 4m. Okay? Therefore, m equals minus a half. Right? And you can see the graph of the blue one is minus a half x minus 2. Okay? Y equals minus a half x minus 2. Okay? So yes, very straightforward. We just, essentially, we are going to plot the graphs and look at taking the point and actually putting it on the opposite side of our mirror. All right? Take, for example, hang on, let's take a parabola, shall we? Just for the heck of it. Okay? Let us take the graph y equals minus x squared plus 4. All right? Well, let's draw that graph. Okay? Obviously, it's upside down, negative, because my standard form is ax squared. A is minus, so it's a sad face. Upside down, and it cuts at 4, and if you work it out, these come to plus 2, minus 2. Like so. Okay, what do I do next? Simple. Next thing I'm going to do is I'm going to let's mirror about the y-axis. Okay? So the y-axis becomes our mirror. So I'm going to draw that in green just for a change. And I take these points and put them there, and this point, and it goes that way. Right? In other words, if I mirror it about the y-axis, the graph just turns and it stays the same. Because why? The y-axis is an axis of symmetry. Okay? It's an axis of symmetry. Okay? Very simple. Now let us say, all right, let's reflect it about and you know what's coming, let's reflect it about the x-axis, shall we? There's my mirror. So I take the point, my real points that I've got, which was 0 and 4, and now I go and find its image. Where is it? It must be blue. That's how far in front. So it must be at minus 4. Okay? 0 and minus 4. Can you see that? So what has happened now? There's my mirror. So my graph has done that. And what is that graph? That graph is y is equal to x squared minus 4. Okay? In other words, it's just flipped about the x-axis itself. Okay? You'll see at the end of this session, the end of this piece, where we talk about finding equations and so on, and flipping. Okay? What do? You take the real points that you can work out. If you haven't got enough, plot them. Okay? Let's look at flipping for example, this graph. Okay? If we're going to flip it about the y-axis, let's draw the y in green. It means that is going to do that, doesn't it? If we're going to flip it about the x-axis, it means that point now goes there. These points then just flip like that. All right? Those are about the x-axis, and the green one is about the y. Okay? These really aren't too difficult, okay? They're quite straightforward things to do. Let's just pause for a second, okay? Let's just say we've got, let's say a look and say we got y equals minus a half x minus 2. Okay? Y equals minus a half x minus 2. Okay? That's the original. Okay? Now we say to us, okay, let's kind of reflect it about the x and the y axes. Okay? Okay? Oops, not minus, it's a half x minus 2. So now they ask us, draw the graph, sketch the graph, okay? So let's sketch it, okay? First of all, standard form, y equals mx plus c. Shape, okay? It's going that way, because m is positive, correct? Let x equal 0, okay? If I put x equals 0, y equals minus 2, and I've got 0 minus 2. Okay, straight away I could have read that off as the y-intercept. Okay, next one, let y equals 0, and we got 0 is equal to a half x minus 2, 2 is equal to a half x equals 4, right coordinate down 4 and 0, and let us go forth and plot. Right, so we say 4 and 0, and we have minus 2, so our graph is over there like that, okay? And we've got our points, now we put them in, 4 and 0, and over here, we've got this guy here as 0 and minus 2. Now, so they're going to now ask us to reflect about, alright, we've got that, okay, alright. We've got those like that. Now, let's go and put in some points. All right, let's say they're asking us to reflect about the y-axis. Right? What do? I move you to minus 4 and 0, and you go down over there like that. Okay? Agreed? Well, you can see all we're doing here is we're just going through the process. Let's look at a totally different graph, all right? The one that I've got over here is y is equal to a half x plus 3. Okay, well, first of all, I've done all the calcs already, so I'm just going to plot the graph here, and I'm going to say, okay, at 0 and 3 is where we're going to go through over there. 0 and 3, and another point was minus 6 and 0 over there, so I had those points over there. Now we plot the points, okay, and we've got the graph. This is our real image. This is the real one, right? This is y is equal to a half x plus 3. Now let us reflect about the x-axis. So let's put that in, I don't know, if you want to, as blue. So what do? I look for, there we go, 0 and 3 goes to 0 and minus 3, because this is the image. Okay? And the next thing I can do is I can now draw this, and I can say, okay, there's my graph. How do I find the equation of this graph? It's y is equal to mx plus c, because we know it's a straight line. For straight away, I can say that's y equals to mx minus 3, because that point there, minus 3, is my c value. And lastly, I just plug in the values that I know. Hang on, let's take this one, minus 6 and 0. 0 equals m times minus 6, minus 3. So what do? I take that over. So m is minus a half. So therefore, my line here is y is equal to minus a half x minus 3. And we are done. All right? Let us say we're going to flip it now about the y-axis. All right, here we go. Y-axis, change it. Look for a point. There it is. Oh, this time, there's my guy that I've got to flip about the mirror. That becomes 6 and 0, doesn't it? All right. So what do? We do exactly the same again. We say, right, y is equal to mx plus c. We know that. Therefore, y is equal to mx. Sorry, let's just draw it. Okay, and we know it's at 3. Okay, And, yep, let's find the gradient. The gradient, you could do it the other way. You could say m is equal to delta y over delta x, right? And delta y over delta x is going to be equal to, okay, can work it out. Okay, it's going to be, let's have a look. Y, let's put in some values over here. What have we got? We've got 6 and 0. So y is equal to 0 is equal to 6m plus 3. Therefore, 3 is equal to 6m minus m is equal to minus a half. So the answer is y is equal to minus a half x plus 3. Okay? And there you have the reflections about the axes. Okay? Let's just look at let's say, for example, I don't know, let's take a reflection of a hyperbola. All right, shall we? Just let's take a standard one, and we say, right, oh no, let's just take one a little more difficult, shall we? Let's say we've got one up here, and down there, and this is y is equal to 1 over x plus 2. So we know this is y equals 2. So that point there is 0 and 2. What are we going to do next? Next they say, reflect that about the, I don't know, let's reflect it about the y-axis first, shall we? Well, let's take, okay, you are red. So what am I going to do? Well, each one of these points must go to the other side. So it's going to do that, isn't it? And this one must all go to the opposite side. I would know that point there, and I'd put it there, right? So that reflects it about the y. We've just taken the top half and swung it, and the bottom half and swung it there as well. And now, let's reflect it about the x-axis, shall we? All right, come on. Well, hang on. Any points we know? There's a point. Let's just check. Whoa. Obviously, we'll have known what that point is. If x is 1, that point is going to be up there. Sorry, my bad. I should put that in black because it's a real point. 1 and 3. So now if I'm reflecting over here, I must change it, right? I've got that point. Whoops, not red. Silly me. Must be blue. Must go down. So 1 and 3 becomes 1 and minus 3. Okay? So you can see that this is all going to flip. So what happens is that this line there goes down, and we end up with y equals minus 2. That guy's going to flip down, so all of those points go there, okay, like so. And this guy is going to flip around like this. Okay? That one's a little complicated, and we'll do one or two of those in the in the next session. Okay, what I'm going to do is the next session we're going to do is finding the equation of the graphs given certain points. Okay, we're going to do a few of those, and then interpreting graphs. All right, and we're moving on rapidly to the end now. Okay, let's take a break, and I'll see you in the next session. And in that one, as I say, we'll look at finding equations. You can see this portion on graphs is huge, isn't it? It's massive. Okay, it's one of the biggest sections. See you in the next session. Cheers.